Okay, this next session is going to be led by Al Dutcher. He's an Extension State Climatologist in the Nebraska State Climate Office. He's also doing this jointly with Martha. Martha not here to give her part, so Al's going to give her part, but they put this together, talk a little more and build more on specifically honing down into Nebraska and some of the changes that we've seen in Nebraska. And he's done a lot of data crunching and looking at numbers. So most of you know Al and have heard Al, and I'll go ahead and turn it over to you. Thanks, Al.
All right. Thank you, Tyler. I'm not trying to try and butcher Martha's presentation. I'll do my best that I can in regards to some of the key items that she would like to bring attention to you from the assessment report. The scenario used, the RCP 4.5, which essentially assumes an increase in CO2 till about mid-century, and then a flatlining of the CO2 concentration in the atmosphere due to the reduction of coal. And we still keep essentially a status quo on oil and nuclear consumption. So when you look at the first thing, 2 to 5 degree average, pushing some numbers this morning to give you an example, Lincoln, Nebraska, for the comparable period that this is based on, 1976 to 2005, the average annual temperature in Lincoln, Nebraska was 51.3, with a spread over that 30-year period from 47 to 53 degrees, just a little over 3 degrees. So we have about a 7-degree spread in that 30 years on average temperature. So if you go on the low end of the scenario, we would be pushing up to the top end of one of the warmest years within that 30-year period. And if we go up to 5 degrees, we would exceed, I believe, anything that we have historically in terms of annual temperatures. Now, as you go into the number of days above 95, and of course, we're expected to see between 20-day increase or so, or basically a doubling. For Lincoln, Nebraska, during this period, we averaged 18 days at 95 or greater, and the highest we've seen was 1983, I believe, with 54 days. You go to the southwest part of the state, Culberson, McCook, which tends to be some of our warmer areas of the state in regards to maximum temperatures. Their average maximum temperature is around 92 degrees. They average 28 degrees, so a doubling would bring them up to around 56 days per year if these models are correct. GDDs increased by 25%. During this period, Lincoln, Nebraska averaged just under 3,700 GDD days. So this would take us up to approximately 4,500 GDD days, or just a little bit more. The thing about GDDs is they're capped on lower and upper base. This is based on a 5086 GDD. So the increases in this growing degree day calculations would be on the spring and the fall period, because our maximum temperatures increase during the summer. The average temperature is above the cutoff threshold on the top. We essentially are gaining our warmth on the low end, on the minimum temperatures. They have shown a pretty significant increase, and we'll get to that here in a few slides. Changes in precipitation. As you can see, and has been talked about, again, we see anywhere from basically a 5 to up to a 15% increase in our precipitation on an annualized basis. And when we break it down further, and we have some confirmation data on this, so this is not out of line with what I'm going to show you here in a little bit. The winter and spring, approximately 20% wetter on average for the state. Fall, a little bit, about 5% wetter. And then as we go into the summer, about 10% drier. The main key issue in the summer for here in Nebraska has been the month of July, which shows a fairly strong dry trend across all climate districts, even though we've seen a wetter trend during the month of June. So when we start to think about these effects, what we're trying to do is find out those situations where we know, or we think with a high degree of confidence, that we're going to see a change, and being able to associate those with potential impacts. And this is where the climate scenario team with Tyler was a lead, tried to get groups of folks across the state in the agricultural sector to start thinking about those type of conditions and the combination of temperature and precipitation where they have problems, or we see beneficial responses so that we could identify as potential areas for us to start looking at to solve some of these situations, or potentially be able to predict these type of situations in advance so that we could take proactive measures. So one of the major things when we go forward in time, and I think that this is a very well written statement, given our inherent climate variability and our local government capacity, I think that the university is well positioned to address this issue. And I always like to say to folks that we should not fear so much the future. Climate projections, whether they're right or wrong into the future, do not mean that every single year is going to follow the same basic path. We are going to see variations, as the period 1976 to 2005, which is compared on this, showed. There can be large spreads, and we cannot basically concentrate on singular events in terms of what we're projecting into the future. So under that guise, in the previous climate assessment report, Nebraska was pigeonholed into the southern plains. We are now into the northern plains, and at that time I knew that some of the projections that were occurring in the southern plains just were not applicable to Nebraska based on some of the climate patterns that I've been privileged to basically look at over my career at the university. And one of the key metrics for me, because I'm so concerned with agriculture, is those number of days above 95 degrees, because they are a stress factor, one of the stress factors we look at in terms of corn. And so we wanted to get knowing that there is a high degree of variability in this state for precipitation from west to east. We needed to know exactly what is happening in smaller regions, because their climate in the Panhandle is considerably different than the climate in eastern Nebraska. And so the process basically was one that, when you consider Nebraska, and we look at Falls City, Nebraska, and you look at the northwestern portion of the Panhandle, we see on average on annual precipitation a reduction every 25 miles, about 1 inch on their annual precipitation. So basically from Falls City to the northwest part of the state, we are looking at an average rate of change of about 18 inches across this state. So we know that conditions in the northwest part of the state under that type of scenario versus the southeast part of the state are going to have completely different outcomes as we go into the future. Secondarily, when I was doing some of my research analysis, and we started looking at clustering of crop yield responses to weather, we've seen some very distinct patterns here in Nebraska. I think Bill Krantz can speak to this, that northeast Nebraska sticks out like a sore thumb in comparison to other areas, and I believe, as Bill has indicated, that their soybean responses up in the northeast part of the state are a little bit different than other areas of the state. And we were able to pick some of this up with a cluster analysis. So that led me to look at those national projections, and one of the problems that I've always had with the national projections is that we tend to want to apply a numerical number to the state of Nebraska. Well, if you consider that, and you consider that when we do a state average based on climate divisions, the Panhandle and north central Nebraska represent over 40% of the surface area of Nebraska. So the Nebraska number, because it's area weighted on the climate divisions, is heavily influenced by the northwestern 1/3 of the state. And so it's important that we be able to separate these areas to see if those trends are consistent. One of the things the national trends do not do, or national projections, is to indicate those short-term indicators. The reason I mention this is it's very common that if we have a cold winter, this means that climate change isn't real. Or we went 17, 30 years, depending on who you talk to, that we have not seen an increase in our temperatures. Therefore, we just throw everything out with the bathwater. What we are finding is that short-term and long-term trends are completely different from each other in numerous instances. They do not invalidate each other. They are part of the process. And the shorter you look at a time scale, the more likely you're going to see more radical shifts in the direction of your trends. So, what we decided to do, and Tyler is going to help me here in a second, is that the first and foremost thing I did, because there's a lot of the folks that have been reading some of the blog sites and realize or think that there is some nefarious thing going on with the co-op data by the national folks, or the federal government, we wanted to look at the Nebraska Mesonet because it's an independent source from the co-op data that goes into the National Climate Assessment. When we did this, we got some trends, and then we learned to turn it over and wanted to do a comparison between that and the co-op data to see if there's commonality, because that is two independent data sets. If they're showing the same trend, then we have a high degree of confidence that what we're seeing is really real. And gives me more confidence that the longer term trends are actually real also if we can mirror 30-year trends in both our independent Mesonet and the national Mesonet, basically, which is your cooperative data. So essentially what we did, and I spent the better part of a year and a half doing this, is that we and I didn't lose my mind doing this, unfortunately, or fortunately, one way or the other, however you want to look at it. We created 3 modes of action to essentially bring this information to you. One is public consumption maps. 2 is a slope table for those that are not inclined just to look at the public consumption maps and want to look and delve deep into what the actual changes are per decade. And the 3rd was side-by-side comparisons of long-term and short-term trends. And the reason for this is to get at that very reason that a long-term trend that shows warming and a short-term trend that shows cooling, we can see that those impacts and where they fit within that line. So all of these files will be loaded onto the Nebraska State Climate Office website. The hope is, and the reason Tyler's going to come up here in a second as I talk about these and he goes through these, is from the simple fact that we want to be able to have the public to interact with the data. And so I can't put these in this. Tyler's going to come up and do this right now and give you an idea of the type of things that we're going to look at. But I will say that in the side-by-side comparison, we've broken that down by climate division. And there is over 1,000 graphs that we created so that you can see these comparisons. All of this data is going to be publicly available. We are not trying to hide anything. All of this was created by, this wasn't created, this was created by Shauna, our communication specialist, but most of the data that was in here is basically boiled down to National Climate Assessment data. So this would be a public consumption map that is available, just to give us a general trends, both short-term and long-term. And then we would go to the data table one.
This one?
That could be it. Each climate division, and this is in the monthly, we've done this for seasonal too. Each climate, yeah, there you go, thank you. Each climate division is color-coded based on a warming or a cooling trend or a wet, and blue represents essentially the short-term indicator and the precipitation. And these are wrong, these need to be changed. I already noticed one error on these. But basically blue indicates getting wetter, warm indicates getting drier in your precipitation long and short term. Now, if we go to the final process here,
this one?
Thank you, Tyler. Can you move that up just a little bit farther? Okay, here's an example coming out of the Panhandle for the month of February.
Oh, sorry. We'll get it.
We'll get it?
Yep.
And what you will notice is that the long-term trend shows a long-established period of warming, and then you see the short-term trend shows a pretty significant degree of cooling. So interspersed in this long-term overall trend is a piece of cooling. The trend has not been interrupted. The only thing that this cooling trend has done is reduce the warming in the long term by a slight amount. How long would it take this current pattern in the month of February to offset the long-term warming, starting dating from 1895 to present? Based on the cooling trend here, we would need another 50 years of the same type conditions that we have seen in this past 30-year period of cooling for us to flatline the long-term trend. So I think it's important for us to understand that just because we go through a 10, 20, 30-year period of cooling does not impede the long-term pattern. We can look back to the 1945 to 1975 period and see a similar type of scenario. Long-term warming was still increasing. We were still showing a decrease in that short-term period, and then we took off again. And one of the thoughts is what we call a stair-step fashion, meaning that at each successive period that you go warming, interspersed by a cooling pattern, you take another step up the ladder. And that would be what the next expectation would be, is after this cooling period, however long it wants to last, and we're only about 15 good solid years into this. If we go another 15 years onto this, what is the next step up going to be? And each one of these steps has added about 1/2 to 3/4 of a degree to our average temperatures. So, we're done with that now. We can go back the other one. What I have done here for you, and I hope that this shows up, is that on the top is a long-term, short-term indicators. This is on our seasonal component. And basically, when you see a plus red here, that means that every climate division within the state of Nebraska has the same similar trend. If you see on the precip, the short-term precip, which is basically from the period 1987 to 2016, two pieces of information show up on the short term. Wet in the short term for the spring, and that's carried through on the annual. This is across all climate districts. Long-term precipitation during the summer and the winter for all climate divisions shows no change on the long term. Short term is a whole different ball game here. But now let's zero down at the monthly, because this becomes more critical. We can look at a 3-month period, but we really need, as previous speakers have mentioned, we really need to know what's going on within each side of those periods. One dominant trend shows up here, and I would draw your attention to the TN-L, TN-S, minimum temperatures, long-term and short-term. A consistent long-term trend, except for the month of September. All climate divisions across the state show the same general warming trend. August, the only difference in August is central Nebraska had flatlined. Basically no trend change in the long term. On the short term, we are starting to pick up some of these cooling trends, but they haven't impeded the long term. The primary things that we are seeing short term is February, significantly, and I do mean significantly colder. If we were to take northeast Nebraska's February trend, project it out to a 100-year time scale, we'd be looking at an average temperature change of, yes, a minimum temperature change, not average, a minimum temperature change of close to 20 degrees over a 100-year period. We know that that's not realistic, and that's the problem with using short-term indicators. It's way overestimating the intensity of that. And Tyler, I'm going to have you bring something back here in a little second when I'm done with this. The other major issue is, as you can see, that the shortest term precipitation is occurring in April, wet across the entire state, doesn't matter what climate district you are. We are also seeing that in the month of June, and we are also seeing that in the month of October. Well, April is planting season, October is harvest season. Two critical issues in terms of how much grain can we get off, how quickly can we get into the fields, how well can we get a crop established, and if these trends continue, is that going to impede our ability or change the dynamics of the type of crops that we want to plant or the length of those crops that we want to plant. The other interesting thing is, in the short term, when we look at February cold trends across the state and May cold trends across the state, the one thing that really comes out on terms of these is the idea of what we call a light switch flip. What we are seeing in the month of December that is consistent is an increase in our temperatures, has meant many of our events more in the form of rainfall than snowfall. We are getting a greater infiltration component in the eastern half of the state for recharge that we normally wouldn't have had because the ground would have been froze. So we're capturing a little bit of that moisture. Unfortunately, when you look at winter precipitation across Nebraska, it only represents 7% of our annual total on average. So just that increase alone is not going to be that significant. We're only talking, in most instances, 1/10 to 1/4 of an inch, depending on the location in the state. Versus if we were to see the same pattern in the month of May, and we see those same percentages applied, we're looking at a full inch to 1.5 inch increase in the precipitation across the state. More flooding events. So, Tyler, could you bring this other one back up? Because I want to use this, and I'm afraid I'm going to screw something up here.
Which one?
The side-by-side comparison plots.
These?
Yes, thank you. It doesn't matter which one we look at. The nice thing about these comparison plots is they provide us with a history of that climate district. And what we can do with this is that we can look at each one of these individual years as a proxy of what might come down the road. Remember, the climate change issue is one where we're basically taking patterns and putting them on steroids, so to speak, making the events, more intense. So if, for example, I'm a municipality and I'm concerned with snow removal, and boy, we had our problems and we had our concerns from the public in Lincoln this year in terms of snow removal. I feel sorry for those folks. I don't think there's anything they can do one way or another to please everybody. But when you look at this year and you look at what we budget for snow removal for the city of Lincoln, some years we have excess, some years we're well short. A typical exercise that I would suggest, and this goes to all applicable areas or sectors of the Nebraska economy, is to take each of these combinations over the last 120 years, push that data through in terms of how the current population and cost structure is per inch of snow removal, and start applying them to find out, do we really have the appropriate money set aside, and do we have an emergency fund for those years when we do have an extreme event like a 1948-49 blizzard event and snowpack that covers a large substantial portion of the country, of Nebraska. That way, what you're doing is you're creating a resiliency. If you're short of funds, your fund over here, basically that reserve fund captures the worst case scenario. Any excessive money is returned back to the public, but you have something to rely on so that you don't have to do some emergency funding type prospects. This is a type of information that we're trying to get folks to start thinking about. Don't be so concerned and freaked out about the change over time. It's not going to be instantaneous, it's going to be over a longer period of time, but the variability is an important issue for us because that determines how much we're going to see changes from year to year. And the nice thing about these graphs, and they may not be able to be seen very well, but you'll notice there's a little bit green lines here, and I think I can show it here. These are the short-term binomial paths, meaning that we're looking at shorter-term trends and an overall long-term. So we can see those changes of the important variables over time. So that's it on that one.
A couple minutes.
Yeah, and I'm just about on my last slide here. Well, I wasn't. Yes, I was on my last slide. So the important issue as we think about this going forward in time is that we know that climate changes. We know that we've seen some specific changes here in Nebraska that correspond to the National Climate Assessment. The most important issue for us at this point in time is to start taking this information, and whether you believe in climate change or not, we know that this flooding event happened. We know that there will be another flooding event in the future of some magnitude that'll probably catch us off guard. The atmosphere exposes us to our vulnerabilities. It's in our best interest to take those exposed vulnerabilities and try to mitigate those in the future. By doing that, if these projections do occur into the future, the impacts should not be nearly as significant. We've taken precautionary steps in advance of those events materializing, and that basically makes us a little bit more resilient and is more effective use of our tax dollars within the state of Nebraska. So that's all I have to say on this. I'll gladly entertain questions. I'll be here through about 12:30, and then I have to go do my afternoon taping. So I'll follow up questions. I'll be more than glad to answer those. I don't know how much time we have, Tyler, for hours.
We have zero time.
We have zero time.
So,
perfect. I love that. I love not having to answer
perfectly
questions.
planned that so they don't.